So in this video, I am going to explain the methods of preparation of yellow herrings. Okay, remember this is very important now. By electrophilic substitution, I will explain to you what is called an electrophile and then what is called nucleophile. You have learned in the 11th standard electrophile, nucleophile. So anyhow, I'll just recollect that later. Suppose say from toluene, if you are taking from toluene. Now toluene is a compound which is benzene ring with methyl group here. So that is called as toluene. Okay, toluene. Now this toluene is also called as methyl benzene. I have already explained to you in the previous videos of mine. If you have not gone through it, please go through that. If you just treat this with chlorine and carry out the reaction in presence of say UV light, or we will take first in the presence of catalyst. I will explain to you other one later. So iron and the absence of light, absence of say light. Then what happens here? That's the difference. There is some students may not know properly what this benzene consists of. So for that part, I am explaining this part here. See, this is continually carbon here at the corner here. This corner, carbon with methyl. Here there is CH. Here there is CH. Here there is CH. Here there is CH, and here there is CH. That H and that H from here, okay, that H and this chlorine will go out as HCl, and what will enter in here? Cl. So I will just explain to you how that Cl go there. So now it will become like this. There will be methyl group will remain as it is. There will be methyl group as it is, and what will go from this? If I want, I can explain this way also. See, chlorine from here, okay, that chlorine will go over here as Cl. How that is formed? Remember, H from here and chlorine from here has gone as HCl. So I will show that HCl. So there will be formation of plus. Okay, I will show you also another possible product here, which can be methyl group over here and chlorine over here in the para position. So there will be chlorine in ortho and chlorine in para position entering here when there is a toluene. Now here, remember that this is major. Which one is major here is the para product, and this is minor. Remember. Now this major and minor, which I can also explain to you all in the form of common name. Remember, I give that common name also. This is called as 2-chloromethane, toluene. I think it is not possible. So this compound that you get here is called as orthochlorotoluene. Orthochlorotoluene. This is a common name, and this will be para-chlorotoluene. So remember that para is the major product. Or IUPAC name become what here? 2-methyl. 1 if I number here, this will be 2. So 2-methyl chlorobenzene. This is called as also 2-methyl chlorobenzene. You can name it that way, or you can also name in another way. You can also call it as, this will be 2-chlorotoluene. Remember, and here once I give this 2-chlorotoluene, this will be what here? 4-chlorotoluene. 4-chlorotoluene. So 4-chlorotoluene is the major, because this is symmetrical. remember here, this is symmetrical, means chlorine and methyl group are symmetrical to each other. That become major. This is unsymmetrical, see it goes like this, okay? Therefore, this is what here? Minor. Symmetrical is major. Alright. So, suppose say, if the same compound was carried out in the presence of, say, the same compound was, chlorination was carried out in presence of sunlight. Suppose there was sunlight here. I'll put it here. If chlorination carried out, here I wrote dark, means absence of light, or I say dark also. Okay, chlorination carried out in presence of sunlight. Now then see what happens here. This I'll show here only. Suppose say chlorination in presence of sunlight. Then this hydrogen from here will be removed by chlorine, and you will get the compound which will be benzene ring with CH2Cl. That will be formation of CH2Cl. Okay, this is called as benzyl chloride. Okay, we can better put it properly so that it not get confused. So I'll put it here. The compound as CH2Cl. Of course, along with that you will get the HCl. Here also along with this you will get the HCl. So this will be called what? Benzyl chloride or chlorophenyl methane. This is called as chlorophenyl methane. Okay. So remember that in the presence of sunlight, you get what? Chlorine will remove the hydrogen from here. And if I continue like this, then you can get here as CHCl2, and then last will be CCl3. So remember that also, that is called benzo chloride and all that thing which I have studied in the last video of mine I have given. Okay, so just see, this is method of preparation of what? Aryl halide from toluene. Now this is substituted aryl halide, remember, because this group here, methyl group here, is a substituted by this thing, the chlorobenzene. This is chlorobenzene otherwise. So this is chlorobenzene. When I put here methyl, that means it's called substituted methyl group. So that's why this is a substituted aryl halide. Okay. Now let me explain the next video of mine. I'll explain to you all by Saint-Maire's reaction how you can get the compound. Okay. So I'll just go and explain to you in the next video of mine.